April 20th, 2010. 11 workers died and 17 were seriously injured by an explosion on the Deepwater Horizon, an offshore drilling rig located approximately 50 miles off the coast of Louisiana. The rig burned for 2 days, eventually sinking and triggering the largest oil spill in U.S. history. During the investigation, the CSB made new findings about why a key piece of safety equipment, the Deepwater Horizon's blowout preventer, failed to seal the well during the emergency. These new findings help explain why the accident was so devastating, and the CSB cautioned that other blowout preventers currently in use could fail in similar ways. Drilling an offshore well involves creating a pathway between the drilling rig and oil and gas reservoirs trapped beneath the sea floor. A deep hole, or well bore, is drilled through layers of subsea rock and sediment. These rocky layers can contain trapped water, crude oil, and natural gas under pressure. An unplanned flow of these well fluids into the well bore, known in the industry as a kick, can be dangerous. Without careful management, a kick can lead to a blowout, the uncontrolled release of flammable oil and gas from the well. A blowout can be catastrophic, since oil and gas reaching the drilling rig can quickly find an ignition source, leading to a fire or explosion, endangering the lives of the drilling crew. To prevent kicks, drillers pump a dense slurry called drilling mud into the well, creating a barrier between the undersea oil and gas and the piping that leads to the rig. If this mud barrier fails or is somehow removed, the safety of the drilling crew depends on a critical piece of equipment located on the sea floor called the blowout preventer, or BOP. The BOP is connected to the rig by a large diameter pipe called a riser. If a kick occurs, the blowout preventer is designed to prevent flammable oil and gas from traveling up the riser to the drilling rig. This is done by sealing the area around the drill pipe, known as the annular space. To do this, the crew can manually close pipe rams and donut-shaped rubber devices known as annular preventers. If those devices should fail to work, the last resort is a pair of sharp metal blades which form a blind shear ram designed to cut the drill pipe and seal the well. The blind shear ram can be activated manually or by automated emergency systems.
The Deepwater Horizon Blowout Preventer, commonly known as a BOP, stood nearly 6 stories tall, weighing over 300 tons, and was designed to hold well pressures up to 15,000 psi. Equipped with 2 annular BOPs, upper and lower, and 5 ram BOPs, consisting of a blind shear ram, a casing shear ram, 2 variable bore rams, and a test ram at the bottom.
At approximately 8:45 p.m. on April 20th, 2010, a kick occurred in the Macondo well. Oil and gas entered the well bore undetected, eventually passing above the blowout preventer and traveling quickly up the riser toward the Deepwater Horizon and the 126 people on board. Just after 9:40 p.m., drilling mud, forced upwards by the rising oil and gas, suddenly blew out onto the rig. Crew members responded by closing the upper annular preventer in the BOP. However, this did not seal the well as intended, and flammable oil and gas continued to flow into the riser toward the rig.
The annular closed around the tool joint and drill pipe. The increasing fluid velocity eroded the rubber annular closing element, the steel drill pipe, and the steel tool joint, preventing the annular BOP from sealing tight. A close-up of the actual tool joint shows the rapid and complete degradation caused by the swift movement of fluids acting like a water jet cutting device, slicing through the metal and creating pathways for continued upward flow of fluid in the space between the steel pipe and rubber annular closing element.
Next, the crew closed a pipe ram. This successfully closed the annular space and sealed the well. But tragically, this proved to be only a temporary fix. Oil and gas that were already above the pipe ram continued to flow inexorably toward the deepwater horizon. As the oil and gas escaped the riser onto the rig, the pressure dropped in the annular space above the pipe ram. But at the same time, the pressure in the drill pipe climbed substantially. The drill pipe was closed at the top, but oil and gas continued to flow in from the reservoir below. After extensive analysis, the CSB concluded that this large difference in pressure likely caused the drill pipe to buckle, essentially bending the pipe off-center inside the blowout preventer. The buckling pushed sections of the drill pipe outside of the reach of the blind shear ram blades. This would eventually prove to be catastrophic. At approximately 9:49 p.m., the flammable hydrocarbons found an ignition source, and the first explosions shook the deepwater horizon. With the drill pipe buckled, the explosion and subsequent loss of electrical and hydraulic power from the rig likely activated an automated system on the blowout preventer known as the AMF Deadman, which closes the blind shear ram and cuts the drill pipe.
As pressure increased, the drill pipe ruptured where the steel had been severely washed away and eroded. Wellbore fluids again flowed upward in the riser to the surface. Without power, the rig was no longer able to remain in position. The rig drifted off location, stretching the drill pipe held in the BOP. Within minutes, the drill pipe was pulled apart, nearly at the same point above the tool joint where the initial rupture had occurred.
This should have cut the drill pipe and sealed the well, greatly reducing the impact of the accident. But because the drill pipe was buckled and off-center inside the blowout preventer, it was trapped and only partially cut.
The drill line was weakened, and the traveling block, best described as an arrangement of pulleys through which the drill pipe is raised and lowered, fell down through the derrick and onto the rig floor. Subsequently, the drill pipe dropped and came to rest on top of the upper annular BOP. Roughly 36 hours later, the Deepwater Horizon sank into the Gulf of Mexico, bending the riser on its way to the sea floor and kinking it just above the BOP.